Hi, very good morning to everyone. So today is my first time in this conference. I'm from Malaysia. I work for the company called Mimos. It actually stands for Malaysia Institute for Microelectronic Systems. We do many things, but we primarily focus on R&D. Although I call it a company, we are 100% owned by the government, which is actually managed by a Ministry of Science and Technology and Innovations. So today, I think I'll cover a few things because in the early days, I didn't know that it's about 20 minutes. So I actually prepared the slides more than 20 minutes. So bear with me. I'll go very quickly. I'll talk a little bit about the landscape in Malaysia, just in case, just to get you in sync where we are today in terms of cloud computing. We'll give you an overview of who is Mimos, what do we do, and also some of the cloud computing activities we do, and some of the use cases in public sectors. So although we are R&D, so that's why the title has a C inside. So the research output from exploring or from investigating new technology subsequently has to go into commercial sectors. So that is how we are measured. We are not measured by number of papers or patents. On top of that, we are also measured by how much of the work that we have done actually go to the industry and how it actually helps the industries. So I'll give you some examples. There are a lot, but I'll give you a few. So just in case people may not know where is Malaysia. Malaysia is a very tiny country in a world map. It's a population of 30 million. These are iconic towers. They are called the Twin Towers in Kuala Lumpur. So this is where we are. So we are in a little corner in the world, but we actually are not new to Open Nebula. We took up Open Nebula about 2012, where we are looking for a infrastructure management software, especially on how to virtualize the infrastructures. So early days, we were in grid computing, high-performance computing. So very naturally, we came across Open Nebula, and based on the design principles, I basically sort of like it, and we took up that, and it has been a journey. So just to start, is just to get everybody understand where are we today in Malaysia in cloud computing. So in terms of a broadband subscription, we are about 40%, and this is based on the 2014 quarter one. We are actually reaching about 50 by now. This is important. Why? Because people are having access to the internet, so they're going to use some the data centers services. So in terms of IaaS market growth is about 59.4 millions. It's 2014. So what is predicted by Internet World Statistics is the business itself, we're going to reach about 723 billions by 2020. So the market is actually there in terms of cloud computing. Those people are actually working on this area. It could be one area that you can go explore in Malaysia. We have good facilities, especially in data centers. So on top of it, this one is not so important. I think the important thing is actually the internet penetration rate is about 70% at the moment. So it means that this area is continuing to grow. All these statistics actually indicating that there will be a very exciting era for all of us. So in Malaysia, under the government agency, we have a strategic planning. So we have 3 agencies is basically looking into this cloud computing initiative. The first one we call Mampu. Mampu is basically a policy, in terms of how clusters, computings are actually used, how to actually modernize the data center for all the public sectors. MDAC is actually the agency work with the industries. So they will work in industry in terms of promoting the technology, in terms of promoting the where the Malaysia is going under the purview of under the sort of a collaboration with Mampu. Mimos is the third arm of it, which is actually National ICT R&D. So basically, in summary, is we are the technology enabler. You work with the local industry, and under a certain governance. So this is how actually Malaysia work. So Mimos, again, is R&D. This is our campus. Currently, we have about 1,000 people. Roughly about 60 of those are actually engineers and researchers. 40% of those are supports. we have kind of unique. We actually have a commercial arm within the government-owned agency. Our marketing team is not so much in terms of closing sales because we are vendor neutral. We can't be seen as competing with the industry, but we can actually aid in terms of assisting industry and tell them the directions where they should go, what kind of technology tips we use, to be precise. So our organization is actually organized according to this is what we call our core area. We cover every perspective of it. We cover data collection, modeling, analytics, visualization, and this is the part that I'm in, called data infrastructure and protections. Under that, we have about 12 labs that is looking at all this area. Back in 2006, we recognized that data, especially now you heard a lot about this big data initiative. IoTs are coming in. Data is actually the next things. So in 2006, we have organized our institute based on these clusterings. And just to be heading, I'm actually I'm the team lead for the advanced computing as well as the accelerated technology. Advanced computing is basically in terms of applied system research in infrastructures. Accelerated technology is high performance. Basically, we're looking at GPU, FPGA, algorithm optimizations. So that is our area. So very quick overview of where are we in terms of cloud computing in Malaysia, as well as who we are as Mimos. So for the next few slides, I will talk about Mimos activities in terms of cloud computing. I will not be technical because I think there's a lot of technical talks already. So, but I'll give you a flavor of what we do. And I think it's more important thing is not doing something good or something neat, which is actually very important when you write papers. But when you actually go to market, it means when you go to productions, I'm sure you hear a lot of some talks about some of the issues that you go into production level. What are the things that you need to be taking care? Because at the end of the day, it's not how cool you have done things. It's how stable it is, how reliable it is. So, and also that's one of the reasons that why we have chosen Open Nebula as our core engine in terms of run our infrastructures, because it's simple, it's small. So it gives us the ability to actually add things, integrated things to it. Because Open Nebula by itself is not sufficient. Let me explain why I say that. So we are in the enterprise solution business. This is typical enterprise kind of things. You have applications, you have framework, you have database security. Underneath you put an infrastructure, you strap in the infrastructure. What I mean is hardware, storage, network. These are very typical enterprise solutions. Where we play. Today we play in the infrastructures level, security and framework. Leaving applications to the industry. Unfortunately or fortunately, quite often we also have to get into this area by instructions because we are government. So government agency, government ministries, they actually will call us up and say, I think you should do this. So we can't say no. You can't say no to your parents, right? They give you the money. So we actually have to abide. But database, we actually stay away because one is the complexity of it, and second, we don't really, we don't really want to get into this market. It's a very stable market. All the brands are quite good, and we are hardware, so-called hardware neutral. We can work with any company, HP, IBM. In fact, we have a very good relationship with this big company. They also set up their so-called the Center of Excellence in our campus, so that they can actually tell us the roadmap, as well as for us to do experiments on those, as well as to figure out what is the next thing to do. So it has been a great collaboration. I hope this trip that it will be fruitful, that we can seal that tie between Mimos and Open Nebula team, so that we can actually do something fantastic here, as well as anybody who is interested. So under this, we actually have developed quite a number of platforms. This is a portion of it, which is actually quite used a lot. I won't go into details of all these things. Currently, we have actually about 60 platforms. Okay, here is about maybe 40% of it are actually here. That is saying that is mostly used. My cloud is actually running, the core engine is the Open Nebula. So as you can see, it's only a fraction of the part. This is actually for wireless infrastructures. This is for server-based infrastructures. And this is video surveillance. Video surveillance is those outside. Today, they're going to move into the so-called IoT devices framework infrastructures. So underneath it, we have this. And here we are actually working with the our so-called clients in terms of providing the solutions, the whole entire stack. So when they come, we will actually mix and match to see what is actually appropriate for them. Okay? I'll be happy to talk to you about some of this network, these things, some of this technology here, maybe next year. I can pick one, okay? Because most of them are actually quite involved in terms of the internal part of the technical part of it. So what we are doing is we actually hit all these vertical sectors. We are in agriculture, E&E, government, health, finance, public sectors, safety, education, communication, and oil and gas. Oil and gas, you most probably know that Malaysia, we have a company called Petronas. It's one of the world producing oil company. We are working with them, but this is more on the HPC side. Recently, we have been working with them on seeing how you actually get the cloud virtualizations of certain clusters so that people can actually get to the data itself, so-called data as a service kind of concept inside. This is very new, but in terms of HPC side, we've been working with them quite some times. Later on, I will give you an example where we are in government, as well as health, some of the health and agriculture, because these are by far the longest term we have been working with them. Like I said, we are measured by how much we contribute to science, as well as how much we contribute to humanity. It means that at the end of the day, it's not how cool is your research output, it's how much of your research output benefited the citizens. This is how we are measured. So in other words, I think here is the same. I think the whole world talk the same language. At the end is dollar sign. How much money have generated for the country. Okay, I take a pause here. If anything you want to ask me. Okay, so for the next few slides, I just give a flavor of what we are doing in terms of how to put all these things together. So as I say, in this picture, what is displayed is actually a very typical sort of enterprise solution, physical solution. You have network storage systems. If you want to do anything in the traditional way, it's actually very time-consuming, it's complex, how to put things together, especially if infrastructure is big. I heard some of the audience here are actually from what's called data centers service provider, ISP. So you will know, running a data center is not an easy task. It's basically very costly in terms of people's equipment and so on. So back in the 2010s, we are looking at this, how to actually simplify the things. So first thing is actually looking at the storage part. I won't go into details. These are some of the key technology I list out here that we integrated together with Open Nebula. So the first part is actually looking at the storage. We were giving a task. Sand storage is expensive, okay? And then commodity storage is actually coming down in terms of price, how you actually make full use of it. I think some of the speaker, I think one speaker this morning has touched one key item is resiliency. The infrastructure, no matter what, need to stay alive 24/7. The application can crash. We don't care. Okay? Of course, if the application is sensitive or if the application is actually crucial, then we need to have a way to actually provide fault tolerance to them. For example, technique like checkpointings and so on. But our principle is very simple. Keep the infrastructure light, keep it alive 24/7, no matter what. Because normally when you talk about SLA, that's the first thing they will get hit really badly if the infrastructure goes down. Okay? So the first thing is actually to see, can we actually replace it by cheap storage? By taking away the sand storage, expensive solutions, take the same amount of money, bring it big. So, and then create an interface and connect it to Open Nebula so that you can actually have a way to actually instruct the storage, the way they actually manage the storage site. So that's one step. Second step is actually enable that disaster recovery. So that, on the other side, you have the same mechanisms. You want to replace it with commodity. and maximizing the resources used between these two sites by having a commodity storage. So that's an important part of it, and this is what we have done today, is to integrate these solutions. And the storage solution is actually based on Ceph. We have done this. It has been a journey for us for about 2 years now. We started about in, again, almost the same time as Open Nebula. At that moment, we were looking at Ceph. We are actually looking for distributed file systems that is highly available and highly reliable, because our data centers is actually far apart. So we want to have a way to, to replicate the data and, okay. So we want to have a way to actually manage this properly. So we did that, but not just looking at this. Why we search Ceph is not just to looking at as a DR site. In fact, there are some principle philosophy behind. First is to get rid of backup. We do not want backup, because backup is sort of an archaic solutions. If you have a highly reliable object stores, things already are replicated. So it doesn't make sense to have a backup, right? So of course, not every application can actually follow that, but most of the application can, because if you are replicated, they are live. The data is there. Second is actually how to maximize use of the DR site as well while you are running it, because DR represents a cost. So if you can actually maximize the use of it, then you can actually have a bigger volume in a sense. Okay? So the third part actually we did is actually looking at the network. Because of the internet connections there, they may be a little bit sort of slow. So what we're looking at is actually OpenFlow in terms of how to actually rationalize the bandwidth. For example, when you are actually doing backup or replications, you want to be able to actually get a bigger chunk of the bandwidth, so you can give it to the backup application and you start to push it. When it's down, you can actually come back to the, sort of a rationale then. So this is the second part we have done that. This is just an instruction, when you need more bandwidth, you give you more bandwidth. And then, of course, because of that, you can actually, then you maximize the server farm between the two sites. Okay? So you actually have some VM clusters here. This is where we actually quite recently we're looking at it, is the way that how to do federation part of that, a federation part of the data center itself. We kind of like the marketplace concept, because there's a lot of things that we can be done. A lot of applications are available. So we have a highly, take advantage of the Open Nebula one flow concept. We have integrated it with OpenKey, as well as some other repository, by putting all them into a single place, have a metadata to describe all the appliances, so that when people log into the Open Nebula, they can actually see this and they can subscribe and use it right away. So this is another thing we have done. So the last part is actually looking at Dockers. We've been experimenting for some way. So I like the last speakers talking about, we are actually taking the last approach, which is actually one flow. It's actually, we look at Dockers as a way to, to expand, to scale your demand, resources on demand. So that is why we're looking at Dockers. But more importantly, not for the server side at the data center itself. Because I think in the data center, you can actually do a lot of capacity planning. In that sense, you can, if you really need, you can actually burst it to Amazon or some other data centers. Not a very, for us, it's trivial, it's good enough. But container is not something we are looking at for the next generations, which is actually in the terms of our IoT, when the devices are actually sitting all across the places, all deployed in all the places, how you actually send a service across there and run the applications over there. So that is why we want the container concept to come in. We are able to, to move the services to across, compute there, because it's closest to the data source. You compute, you're done, you bring it back. Only the data is required to bring back, instead of all the things are coming back to your data centers. Okay? So on top of it, we put a security solution, what we call a UAP system, Unified Authentication System. This one we have integrated with Open Nebula. So in our Open Nebula Sunstones, actually we take away your login, we put in UAP. It's meant to be a single sign-on. It has a few capability. It actually supports multi-factor authentications depending on time. It can depend on time, can depend on 2D barcode, OTP, SMS. It can challenge depending where you log in, how you log in. So it has given us a unified sort of a login, not only for system administration side, but also ability to for the application to connect so that you can have a single sign-on concept inside. On top of it, for security part, we actually take some advantage of the what we call the TPE, Trusted Platform Modules, which is actually normally tied into your server, your motherboard. So the only question is how you actually link it back to the virtual machine so that your virtual machine, you know that it's not being tampered. So the whole idea is if you keep you did a checksum of it, keep the information in the hardware. If the system is actually being hacked, then you can actually restore the original version of it. So these are all can be automated and detected on runtime. This is an important issue. We started this because some of the ministers' web pages were hacked, so they came to us. So we look at this. Our engagement quite largely involve documents, ministry, governments. So it's a way to how you actually not only to detect the changes, but you also need to be a way to monitor them, find out if there are changes. If there are changes, you want to record that and report the incidents. And on top of it, you want to be sure that there is no way, the way that the document can be actually sent out. So this is actually built inside to our so-called cloud solutions. Okay, so these are some of the effort that we have done in order to put all these things together. There's a lot of work that's been done. I think maybe you can talk to me about all this. So I think this is an interesting part where we use it. So first example is agriculture. Sensors is the product. By itself, it's not interesting. In fact, we produce these sensors, especially the tips part. So once you have the sensors, you need a management systems. You need a Wi-Fi infrastructures. You want to have a cloud sort of a database virtualization in order to monitor the systems. So you create an ecosystem of the product. Then you actually have to link in the other sort of information, which is actually you get supply chain, market aggregator, all this. So we have put this as a complete solution for the Ministry of Agriculture. So today, the sensors, many different kinds. So this is the interesting part. One of the examples what we did is actually called Intelligent Pollination Management Systems. So what happened is we deploy the sensors into the palm tree. Palm tree, what we're trying to do here is, you see this back here? This is the palm seed. So what we call it mother palm. So every once in a while, the guys have to climb out, hug the palm, make sure, this is a traditional way of doing it. It climb out the tree, hug the palm and say, it's warm enough. It's warm enough, they pollinated it. Okay? It costs a lot of money. Each time they cost, I think it's about 10 euros to climb the tree. Okay? So they can climb as many times. So what we have done is actually put sensors across. We have a Wi-Fi solution to it, and then ship back the data into a so-called management system running at the data centers. And then from then on, we can actually monitor the same ideas to every other places. Some of these things are interesting. The other one we have done is actually for the prawn. This guy is a prawn. So this is one of this square area is actually one soccer field size. So this is huge. You put that, you try to understand the water level pH in order to make sure that the prawns stay alive. It's a big business, a multi-million ringgit solutions here. So we have put all these things together. They're running in data centers. Why we use virtualization? Because sometimes the demand is higher. We can actually increase the resources as we go. The other thing is we've done using a similar framework. We actually do food safety traceability from end to end. Okay, one of the good examples is something this is the most smelly food in the world, what we call durian. Don't laugh at this kind of food. One seed of this, it costs about 50 ringgit. So it's about 10 euros or so, about 8 euros to sell in China. So they want to make sure that this durian actually comes from the place where it claims it comes from. So we have to put a 2D barcode, use a mobile device, and so on, and to track that. All these are feedback to the data center to mobilize. The other thing is agribazaar. So this is actually what we call the supply and demand matching. So if you are looking for so-called chili producer, we can actually match you to different place. I think some of this is in Malay. You won't be able to understand. But again, using the same infrastructures, we are able to do that. Government sectors, Job Malaysia's, we have done that. I think in the interest of time, I just want to quickly just mention this. Is harvesting data. Basically, we send out a robot to actually mine all the open data that we have of particular interest. Here we are more interested in, then we categorize them and we actually present the result to the customers. Okay? In this case, it will be the ministry who are interested. Who are the people talking about them? Why are they talking about them? What are the issues? So one of the areas we deploy this technique is actually for the Malaysia Complaint Bureau, because before that they also always have to wait for the papers, someone sending letters. So a lot of times they don't quite understand what happened on the field, like people writing on the blogs and all this. So we can actually mine all this and basically present a summary of that. So the next thing we actually take is actually called sentiment analysis, okay, to understand how people think about certain things. Okay? This is a Malaysia outcome-based budgeting system. It's a national budgeting system. It's again running on the cloud. This one is complex. I leave it. Another thing is called the health data center. Basically, you have all the hospitals. They have all the different information. They want to fit it in so that you can do. So this is how we actually apply the infrastructure side, as well as build some application into that. So moving forward, I think we are already in the big data. These are the 5 pilots project. One is to actually look for terrorists. We don't call it terrorists, we call it Islamic extremists. Weather, economy models. Some of these are actually quite interesting that we are working around. So we have actually crafted the whole entire solutions. This is basically big data, so-called data platforms. On top of it, you put all the infrastructure. Cloud is one of those that actually support the underground for this. So this is we are going in. With that, I just stop here. Okay, this is just a flavor of what we do. There's a lot of things, a lot of frustrations, but I think it's not good to share frustration. Right? We should share something positive. So these are the positive outcome of all this. By putting all these solutions together. I think I want to stress one more thing. Well, since I'm here in the Open Nebula conference, Open Nebula, I think I have, we look at it as a very promising technology. Unfortunately, it's not very well known, at least in Asia. So I'm hoping that I actually bring this technology back and tell people how good it is. It's not because of so-called religion kind of thinking. It's really based on understanding of how Open Nebula actually built. Like I say, keep it light, keep it simple, then everything will be fine. Because when you go out to the solutions, it's all about integrations. If you have something like OpenStack, we're looking at OpenStack as well. If you have OpenStack, you'll be just sitting there watching at it and you're not really sure where to start. And I have quite a big team. I actually have 60 people under me looking at these things. So Open Nebula, good, 60 people. OpenStack, maybe put a 0 there, another 0 there. No, there's so many. It's a fantastic OpenStack. I'm not trashing them. It's a fantastic technology-wise. They have very good concept, very good. It's just that it's huge. You just don't know how to manage it. When you go for research, it's okay. When your timeline is not critical, it's fine. Our project normally lasts for about 6 to 18 months. That's it. Then everything goes live. If we can handle it, no problem. Okay? So, thank you very much.
Thank you, Paul.
Thank you.